So what we're going to go ahead and do is we're going to clarify a couple of things. The first thing is when we have a horizontal line, that's a line that runs parallel to the x-axis. So here I have a picture. Where it goes through the y-axis at is point B. So our equation is y equals b, and our y-intercept is the point 0, comma b, because that's where it goes through our y-axis. For a horizontal line, our slope is 0. We also have vertical lines. These run parallel to the y-axis, so up and down. Where they go through the x-axis, so point A, that is our equation, x equals that number, and that's also our x-intercept at a0. The slope for a vertical line is undefined, okay, because I can never have a vertical slope. So what we're going to do is we're going to practice writing the equations of lines that run parallel to certain axes and through certain points. So this first equation, I want to write the equation of a line that runs parallel to the x-axis, so horizontal, through the point -3, -4. So the first thing I'm going to do is I'm going to go ahead and graph. And I'm going to find the point -3, -4. Once I find that point, I'm going to go ahead and draw the horizontal line that runs through it. It goes through my y-axis at the point -4. So my equation is y equals -4. If you notice, that's also the y-coordinate for my point. So using that same logic and that same information, if I have a line that runs parallel to the y-axis, so is vertical, and goes through the point -3, 4, my equation is probably just going to be the x-coordinate of that point. Well, let's graph it to make sure. So I'm going to find -3, -4. I'm going to put a point, or put a dot, and I'm going to draw the vertical line that goes through that point. Hey, guess what? It goes through x equals -3. So now we're going to go ahead and look at forms of lines. So the first one is point slope form. These are all lines that go through the point x1, y1 with slope m. So my first one for point slope form is y minus y1 equals my slope m times x minus x1. As you probably guessed, to write something in point slope form, I have to know the point and I have to know the slope. We also have slope intercept form, which is y equals mx plus b. M here is our slope and b is our y-intercept. We usually have to start in a different form in order to get it to slope intercept form. Our last form is standard form. This is ax plus by equals c, so it's just our x term in front of our y term. There are some stipulations, of course. Our a value in front of our x cannot be negative, so it has to be a positive number, and it also cannot be a fraction, so it has to be a positive whole number. So what we're going to do now is we're just going to practice using those equations. So I would like to write the equation of the line through these 2 points and we're going to start in point slope form. That's usually where we start things out. So if I want to write this in point slope form, I have to know 2 things. I have to know a point. I have 2 of them, so I'm good there. And I have to know the slope of the line. I don't have that, so I need to calculate it using our nice, awesome slope equation, which is y2 minus y1 over x2 minus x1. This gives me a -5 over a -4, which reduces to 5 over 4. So to write this in slope-intercept form, I'm going to use the point 1,7 just because it's convenient. You can use either of the points. It'll still work out the same. So I have y minus 7 equals my slope 5/4 times x minus 1. I have a fractional slope, so there's 2 ways you could do it. You can either multiply the slope into this x minus 1, or we can split it up and divide out later. My goal now is to change this point slope form into slope intercept form, just to see what can happen. So I'm going to split it up. I'm going to kick the denominator 4 over with the parentheses over here, and leave this 5 with the parentheses over there. When I do that, I get 4 times y minus 7 equals 5 times x minus 1. We distribute, I get 4y minus 28 equals 5x minus 5. Add the 28 over, 4y equals 5x plus 23, and then divide everything by 4. So I get y equals 5/4 x plus 23 over 4, and this is our slope-intercept form. Now I want to try and write this in standard form, just because I think it'd be fun. So I'm going to go back to this step before I made everything into a fraction. And I have 4y equals 5x plus 23. Standard form has to have the x in front, so I need to subtract this 5x over. But I know that for my standard form that my x value cannot be negative. So now I need to multiply everything by a -1. And I get my standard form equation. So using 2 points, we were able to write all 3 different equations for this. So what we're going to do now is we're going to graph a line, because we could always use more practice for that. So I would like to graph the line 2x minus 5y equals 8. So the first things first, as I'm looking at this, it's pretty obvious that this is in standard form, which is awesome because we could always use more practice with that. But from standard form, I can't really pull out any information. So I have 2 options. I can either change this into slope-intercept form, which would give me my slope and my y-intercept, or I could go from here and just find my x-intercepts and my y-intercepts and graph those. I'm going to go with that one just because I think it's good practice. So we're going to find our x-intercepts first. To find our x-intercepts, we plug 0 in for y. So I get 2x minus 5 times 0 equals 8. 5 times 0 is just 0. So I get 2x equals 8, which means x equals 4. So my x-intercept is 4, 0. I'm going to do the same thing now, finding my y-intercept. So I'm going to have, to find the y-intercept, I plug 0 in for x. So I get 2 times 0 minus 5y equals 8. 2 times 0 is just 0. Negative 5y equals 8. Divide each side by -5. And I get 8 over a -5. So my y-intercept then is 0, negative 8/5, which is negative 1 3/5. So now I can go ahead and graph this using just those 2 points. I'm going to go ahead and graph 4, 0 first, which is my x-intercept. Then I'm going to graph 0, negative 8/5, which is between 1 and 2. That is my x-intercept, and then I'm going to draw my line. So as I'm looking at lines, there's a couple other things that come to mind. First off, 2 lines are parallel if they have the same slope. Similarly, 2 lines are perpendicular if their slopes are negative reciprocals. I'm going to go ahead and show you an example of parallel lines just in case you can't remember. So 2 lines that will never intersect versus perpendicular lines that intersect at a 90-degree angle. So we're going to use this information to write the equation of a line through point 5, -7 and parallel to 6x, oh gosh, 6x plus 3y equals 4. I'm just going to do point slope form because it's going to be easiest. I have the point, but I need to find the slope. Well, I know that my line is going to be parallel to that line, so I need to figure out the slope of this line right here. To do that, I don't have a second point to go off of, so I'm just going to put this in slope-intercept form. So I'm going to subtract the 6x over and divide everything by 3. The number in front of x is our slope, so here that's -2. My line will also have a slope of -2 since it's parallel to that one. So using point slope form, I have y minus a -7 equals my slope -2 times x minus x1, which is 5. I reduce this a little bit more by making this y plus 7 because it's a double negative, equals -2 times x minus 5. From here, I could distribute the -2, combine like terms, and so on. But I'm not going to do that because I don't think it's super duper necessary. So let's do another example. This time, I want the equation of the line that goes through the point 5, -7 and runs perpendicular to 6x plus 3y equals 4. So again, I have a point, but I don't have a slope, so I need to calculate that. To do it, since I have a line, I'm just going to put this in slope-intercept form, which gives me 3y equals -6x plus 4. Divide each side by 3, and I get -2x plus 4/3. So -2 was the slope of the line that's running perpendicular to mine. So to find my slope, I need to take that -2 and put it into a fraction. I'm going to multiply it by a -1, and I'm going to flip it over. So when I multiply by -1, this becomes 2 over 1, and when I flip it over, it becomes 1/2. So my slope is 1/2. It's called the negative reciprocal. We flip the fraction and take the opposite sign. So again, using point slope form, y minus a -7 becomes y plus 7 equals my slope 1/2 times x minus x1, which is 5. Any questions there? If so, please email me. So the next example we have is going to be the last one. There is another one in the notes that is a bit of a story problem, but I think you can work through that one on your own. I hope that the video does not cut off. If so, the rest of the examples in the notes, I'll try to do another video. I went ahead and wrote this. The first thing I need to do, since I want to find the equation of the line that is perpendicular to segment AB, so I want the perpendicular bisector, which means it goes through my midpoint. I need to find that midpoint. So that's our x's added together and then divided by 2, and our y's added together and divided by 2, which comes out to be 2 over 2, comma 5 over 2, which reduces to 1 and 5/2, so that's the point that mine's going to be going through. I know that I'm trying to find the equation of the perpendicular bisector, which means it's going to have the opposite slope of this one, so the negative reciprocal of it. So I need to calculate this one's slope first. 4 minus 1 is 3. 5 minus a -3 is 8. So this slope is 3/8. My slope will be the negative reciprocal of it. So I need to flip it over and take the opposite sign. So my slope is -8 over 3. Now all I have to do is write the equation of the line that has that slope and goes through that point and put it in point slope form. So I have y minus 5/2 equals my slope, -8/3, times x minus 1. The last example is on Canvas. Please let me know if you have any questions.